All right, number five. Number five, what do I see in common? Okay, something that catches my attention. It's going to be k squared. Let's get the k squared out. K squared plus 7k minus 30. Okay, so how do I break down this quadratic trinomial? I'm thinking about 6 times 5 to get 30. I'm thinking about 3 times 10. So which one is which? It's going to be 3 times 10. Why? Because of this. Because the outer is going to give you positive 10k and the inner is going to give you minus 3k, and that's how you get positive 7k. Right? Keep going. What do I see? I see multiples of 4 and I see a c right there. So let me go ahead and take the 4c out. 2c squared minus 9c and then minus 5. Okay, all right, so how do we factor the quadratic trinomial? Well, thankful we have a prime number. 2c times c is 2c squared. Now, because you have a plus, you have a minus and minus right here, then we know the signs right here is going to be one positive, one negative. And because the first terms are different, I cannot put any plus or minus right in the parentheses at the moment because the first terms are different, okay? It would matter a whole lot. Now, I'm thankful for the 5 right here being a prime number because, prime number, that means it's going to be 1 times 5, 1 times 5. So, do I get the answer? Yes, I do. What's the answer? 5 here, 1 right here. It's going to be minus, it's going to be a plus. How can you do it so fast? How do you know? Because my mental math already got me negative 10c and positive c. That's going to give me minus 9c. Okay? Trial and error. It's all mental math. Okay? Got to step up the game. Number 8. Number 8. Okay? Anything that I spot out in common? I think there's a 5 right here. 65 is not a multiple of 15. 50 is not a multiple of 15. So just a 5. Nothing much. All right, 5 be 13c, and then that will be 10, right? So again, if you're skeptical, always multiply back in to see if they are equal. If they're equal, you're good, okay? It's okay to be skeptical. Just make sure that you know how to prove yourself. And now, what can we do? We know it's going to be 3c times c because 3 is a prime number. What else do we know? It's going to be a plus and a plus because, oh my God, no, it's not a plus and a plus. Can you see why? Can you see why? Because there's a minus right here. So the plus right here could come from 2 positive numbers or 2 negative numbers multiplying together, and because of the subtraction right here, it's going to be minus. All right? So now, the challenge. 1 times 10, 2 times 5. Which pair? How do you get 13? How do you get 13? Or negative 13? Well, I got it. It can only be this. Because why? Negative 10c. And then, oh no. Oh, I'm sorry, my bad. Why am I putting a 3 right here? That's stupid. It's a 1. 1 times 10, right? Sorry. Negative 10c and then negative 3c. That's how you get negative 13c. Okay? So, trial and error. Now, what happens, okay, if you say, hey, what happens if I did not factor the 5 initially? It's going to be painful. And why? Well, do you remember how I said be grateful for prime numbers, right? If you see prime number like a 3 right here, great, because it can only be 3c times c. If you don't factor out the 5 out of all 3 terms, well, go ahead, have fun figuring out which kind of combination is going to be. You just double or actually quadruple your workload because you have now more combinations to consider. It's going to be disgusting. Like 50, think about what? 1 times 50, 2 times 25, 5 times 10, right? It's disgusting. But when you factor out the 5 out of all 3 terms, you have much fewer combinations to consider, which is great. All right? Ooh, this one's a challenge. Now, This one is a challenge. It's a good challenge. Okay. Here's how we do it. Okay. Now I will show you a typical way that we do it in Algebra 2, and then I will show you a little simple way that might help you transition. So the thing here is that whenever you see anything raised to the fourth power, it's special. How special? This special. This is how you get c squared. I mean, this is how you get c to the fourth power. Okay? This is how you get c to the fourth power. Why is it important? Because now you need to learn how to look at c squared as a single entity. Okay? So what do? You'd be like, oh, okay, all right, c squared, because c squared times c squared is how you get c to the fourth power. Okay? Now, if you are having some difficulty, just bear with me. I'll show you a different way, but try to get more exposure. All right. All right. Now, how to get 9? 1 times 9, 3 times 3. Which one is which? It's going to be -9 plus 1. How do we know? Because that is the only way you can get -8c squared. You have -9c squared. You have positive c squared. That's how you get -8c squared. That's how you know. Okay? But the challenge now, anytime that you see a number raised to the fourth power, you got to be careful. Because why? We're not done yet. And a lot of students, they would finish this problem prematurely. They did not see something special. What is special over here? Ooh, this is special. Can you see how special this is? This is c plus 3, c minus 3. And since we didn't touch anything here, we just keep writing it. Okay? When you multiply these three things together, it shall give you c to the fourth power minus 8c squared minus 9. All right? So that's how you would do it. That's how you should do it for the future. Now, as I promised, I said there's a different way to look at this, to transition you, okay, through this challenge. So what you can do is this. You can say, hey, all right, you still have to look at it this way, but say, oh, can I go ahead, make things look a little bit nicer, and say, let a be c squared. So what you will have is to change c squared to be just a squared. 8 times c squared becomes 8a, and then you have this. You'd be like, oh, that I could do, all right? All right, all right. Now, the problem is a lot of students, if they do this, they might just finish it right here, and they didn't know they have to put the c squared back in. So that's two extra steps, because you have to replace the c squared with a, and then you have to put back the c squared in place of a. And then you still have to realize that, hey, that's a squared plus b, a squared minus b squared. I'm sorry, a squared minus b squared. So this is still your final answer. So I'm going to let you choose which way to go. I can tell you what I prefer. I prefer this. You need to prefer this in the near future. If you rely on this, for now, I'm okay. Okay, but you bear your own risk. And that is, do not end the problem prematurely. The variables are C. And if you are writing equal signs, right, every single step along the way, all these equal signs, you just look at the front and look at the end. Do you have C's? You have to have C's. The A is like a little transition to get us through the hoop, but you still have to put the c squared back. Okay, and then you realize, ooh, something more to be done. Okay, make sure you are fully aware of it. This one. All right, now, let's factor out the c squared first, since I see a c squared for all of them. All right, now, let's see if you can spot out something special. All right, take a moment. Understand how we can get to see these factors. Okay. Now, Here's how I see it. Remember earlier, I told you that be very sensitive with all these like numbers. Whenever you see like, oh, I can see some connection, like 5 times 2, 5 squared, right? These combinations, they are not random. When you see 25 and 10, you start to ponder, like, is that something special? Yes, it is. All right, so now let me go ahead and write the little step to help you see it. So the way you look at it is like this. 5c squared plus 2 times 5c plus 1 squared. 1 squared is 1. That's how you know it's a squared plus 2ab plus b squared. Now, if you want to see the 2ab, let me put back the 1 right here. You can see it. Experience. Pure experience. Okay? That's why you got to drill. And I'm sorry. I'm sorry. It does look boring from time to time, but guess what? Guess what? I'm going to use woodworking as an example because I do a little bit of woodworking. Okay. I need to use these saws, like those electric saw, like table saw, miter saw, you know. Oh, here, let me show you a little picture of miter saw. What is it? Miter, oops, miter saw. Okay, all right. That's called miter saw. You want to make some good craft, you need to use these saws. And you know what happened to a lot of people when they're not super familiar on how to operate this? They say goodbye to their fingers. And they're gone. Their fingers are gone. They're detached. You cannot put back in. So this is where we are right now. Yes, it's skill building. Yes, from time to time, it's a little bit boring. If you play the instrument, you might know what I mean. You know, if you play the piano, you gotta practice these chords or scale, right? You gotta learn. I can give you one promise, and that is when you go to calculus, it's a very different vibe. But to enjoy the amazing feeling of calculus, you've got to do your work. And that is build all these basic skills to the point you are fluent. If you are not fluent with these factoring skills, it's not going to fly. It simply won't fly. Okay? So, all right, now for the next video, I'm going to handpick a few questions that are very, very special. And I will just go over those in particular. All right?